Hello everyone. In this second part of the series on ethical data cleaning using Python and handling extreme values in a data set. What are extreme values or outliers? Should we remove them, keep them, or replace them? In this second part of the series on ethical data cleaning using Python and object-oriented programming, we dive deeper into understanding extreme values, also known as outliers. What happens to the data set when extreme values are present, whether unusually high or unusually low? How do they change the shape and distribution of the data? Do they create skewness, distort the mean, or inflate the variance? In this video, we examine how outliers can stretch distributions, shift central tendency measures, and mislead visual interpretations. We also discuss their serious impact on regression models, where a single extreme point can drastically change the regression line, and on time series analysis, where abnormal spikes may distort trend and forecasting accuracy. Most importantly, we explore ethical decision making in data cleaning. Should we remove extreme values? Should we transform them? Or should we retain them because they carry important information? By the end of this session, you will understand how to handle extreme values responsibly while preserving the reliability and integrity of your data analysis. Consider some outliers. How does these outliers occur? These outliers can occur naturally, and also this can occur due to errors. Outliers can occur naturally due to unusual events. During the COVID-19 pandemic year, industrial production declined significantly. GDP growth across several sectors slowed down, and the number of deaths increased markedly. When yearly data for these variables are analyzed, the pandemic year appears substantially different from the preceding and subsequent years. Such observations stand apart from the general pattern of the data and may be identified as extreme values. However, these are naturally occurring outliers arising from real-world structural changes rather than measurement errors. Similarly, during a severe flood in a particular state, agricultural production may decline sharply compared to other years. In such cases, the unusually low production values reflect genuine external shocks. These observations, although extreme, represent meaningful and context-driven variations in the data. These observations represent naturally occurring extreme values, not measurement errors. Now let us consider occurrence of outliers due to errors. How do outliers occur? Are all extreme values real, or can some of them be created by mistakes? Let us think about data entry. What happens if the age of a mother is entered as 8 instead of 18 in birth registration data? Immediately that value becomes an extreme observation. Similarly, if a welfare amount is recorded as 5 crore instead of 50,000 because of an extra zeros, the data set suddenly contains a misleading outlier. Can measurement errors create outliers? Yes. faulty instruments or incorrect recording of values can generate unusually high or low observations that do not reflect reality. What about data collection? Respondents may misreport information or surveyors may record responses incorrectly. These errors can also produce extreme values. And even after collection, can errors still occur? Absolutely. Coding mistakes, incorrect data transformations, or errors during merging can introduce artificial outliers into the dataset. So, are these extreme values meaningful? No. Unlike naturally occurring outliers, these arise due to inaccuracies. Therefore, they must be carefully identified and corrected before proceeding with statistical analysis. Sometimes outliers tell a story. Sometimes they reveal hidden patterns. Sometimes they warn us that something unusual is happening. So before removing an outlier, we must ask, is this value incorrect or is it carrying important information? Now, let us understand the statistical definition of an outlier using a practical example. Suppose we collect data on the price of coconuts from different districts of a state. After arranging the prices in ascending order, we divide the data into quartiles. The first quartile, Q1, represents the price below which 25% of the districts fall. For example, if Q1 is rupees 5, it means 25% of the districts have coconut prices below rupees 5. The second quartile or median represents the middle price. If Q2, second quartile is rupees 7, it means half of the districts have prices below 7. The third quartile represents the price below which 75% of the districts fall. Suppose it is rupees 9. The interquartile range is Q3 minus Q1, which means interquartile range measures the spread of the middle 50% of the prices. Now, if any district reports a price lower than first quartile minus 1.5 times interquartile range or higher than third quartile plus 1.5 interquartile range, then that price is considered as an outlier. Such a price would be unusually low or unusually high compared to most districts. Now, let me ask you some curious questions. If one district reports the coconut price as rupees 20, while most districts range between rupees 5 and rupees 9, should we accept it immediately? Could it be due to transportation cost or shortage? Or could it be a data entry mistake? Or could they tell something more important about market conditions? These are the kind of questions that make outlier detection meaningful. Outliers are not just numbers outside a formula. They are signals that require investigation. Now let us consider the effects of outliers on data. Outliers have a strong impact on data analysis. First, they inflate the variance, making the data appear more spread out than it actually is. Second, they distort the shape of the distribution. If we have very high extreme values, the distribution becomes positively or right skewed. If we have very low extreme values, the distribution becomes negatively or left skewed. Outliers also shift summary statistics such as mean, which can lead to misleading conclusions. Finally, when we build statistical or machine learning models, outliers can affect parameter estimation and lead to poor predictions and forecast. So, we have discussed the effects of outliers on data. This can inflate the variability. This increases skewness, positive or negative, shift summary statistics, affects model result. So here I have taken an example by showing that after when an outlier comes, the mean, variance and also the shape of the distribution will change. So let me tell an example for this. Suppose we are estimating the average yield of sweet pepper per plant in a state. We collect data from different farms. Most farmers report yield between 2.8 kg and 3.5 kg per plant. Now, imagine one farmer reporting the yield as 0.5 kg per plant, which is extremely low compared to the others. Let us think carefully. If we calculate the average yield including this very low value, what happens? The mean yield will decrease. The variance will increase. The distribution may become negatively skewed. Now the estimated average yield of sweet pepper for the entire state will appear lower than the true typical yield. But we must ask, is this low yield genuine? Was there pest attack or poor soil condition? Or was it a measurement error? Or maybe someone recorded 0.5 instead of 3.5 by mistake? If the value is an error and we include it in analysis, our estimate becomes biased. If it is genuine, then it tells us something important about variability in farming conditions. So what do we learn? A single extreme observation can significantly affect the mean yield, the variability, policy decisions, agricultural planning, forecasting of total production. See here, I have taken a data on yield and here I have got mean as 2.62, standard deviation as 0.2094. Now the histogram looks like this, almost normal, and if I add an extreme value 0.5, look how the mean changes. Mean it becomes 2.46, standard deviation 0.62, and also has increased, and also the histogram changes, the shape of the histogram gets changed. Now let us discuss how can we deal with these outliers. So the first step is to detect the outliers. Next is to print rows containing outliers. Next is investigate possible causes, whether to replace outliers or not. Depends on the type of data and type of analysis required. If the outlier occurs due to data entry errors, replace outliers with correct value. Replacing outliers. Winsorization. Replace extreme value by percentile. Values below are chosen lower percentile and values above are chosen upper percentile. Next is quartile capping. What is quartile capping? Lower outliers are replaced by quartile 1 minus 1.5 times interquartile range, and upper outliers are replaced by quartile 3, third quartile plus 1.5 times interquartile range. You can also replace this outlier by average or any arbitrary value as you like, and all or using regression estimates. Now you can also remove outliers. Trimming is the means fixed percentage of the smallest and largest observations are removed. You can also transform the data so that normality will come. The data becomes normal instead of skewed data. So you can use logarithmic transformation, square root transformation, or box-Cox transformation. In the next session, we will focus on handling outliers. We will write functions to remove or replace extreme values and then organize everything using an object-oriented programming approach as we studied in the earlier video. You can watch the earlier video to know how we can use object-oriented programming for data cleaning. This will help us build a clean and reusable outlier handling module. So this is reusable. You can take any data and this can be used for any data. If you find this content informative, don't forget to like the video and subscribe to the channel for more such tutorials. Thank you.